Hey guys, so um, today we're going to be talking about probability of multiple events, more than one. Um, so just to refresh, probability of a single event. With these ones, I recommend you write out the sample space. So a bag contains 3 yellow tickets numbered 1 to 3. So you got yellow 1, yellow 2, yellow 3. The bag also contains 6 green tickets numbered 1 to 6. So you randomly pick a ticket. It is green or has a number greater than 2. So that means you would circle everything green and everything bigger than 2, which would be 7 out of 9, not 7, 7 out of 9. Which, if you put 7 divided by 9 in the calculator, you get 0.7 repeating. So about 0.78 if you round. So that's how you do a probability of just a singular event. Well, with multiple events, you're basically going to take the two probabilities and multiply them. Simple enough, right? The only thing is you have to be careful to pay attention to whether or not the two events are independent or dependent. So if they are dependent, it means that something has changed. So no replacement is kind of what you're looking for. Basically, it'd be like if you drew a marble out of a bag. Well, if you don't put the one you drew out the second time you draw a marble, it's different. So something changed. So this usually affects the total, the bottom number. Now this will make more sense when I do an example. Okay, it can affect the top number, but anyway, if it's independent, then if you took the marble out, you did put it back, so there is replacement. Or they just have nothing to do with each other. So one or the other of those two things. So I think it makes more sense when I do an example. So I'm going to go ahead and show you what I'm talking about.
Yeah, sure.
So for this problem, there are 7 nickels and 4 dimes in your pocket. You randomly pick a coin out of your pocket and place it on the counter. So for all of these, it says to say whether it's dependent or independent. So if you put it on the counter, you did not replace it back into your pocket. So that one is dependent. So that means the bottom numbers are going to have to be different. So you can just put a D or an I for dependent or independent. Then you randomly pick another coin. Both coins are nickels. So the first draw, the chances of getting a nickel is 7 out of 11. But then you take one of the nickels away. So you have 7 nickels, 6, 7, and 4 dimes. So you take one of the nickels away because it's on the counter now. It's no longer in your pocket. So now the chances of getting a nickel is 6 out of 10. So that's why dependent matters. If it was independent, it'd be the same thing both times. But for dependent, it matters. So then you would just do 7 divided by 11 times 6 divided by 10. And you would get about 0.38. So about 38% chance. Okay. So this next one, you flip a coin twice. The first flip lands tails up. The second flip lands heads up. Well, that's what I mean when it's like totally separate. Like one has nothing to do with the other one. You know, you're not pulling things out of a bag. Like flipping a coin, one flip has nothing to do with the other. So that's independent. And both times it's just 1 out of 2. So if you multiply those together, you get about a 0.25. Okay. So, other example, a bag contains 3 red marbles and 7 blue marbles. You randomly pick a marble and then return it to the bag. So if you returned it, that's what you're looking for. Did you return it or did you not return it? So this one would be independent. So a bag contains, so both the first and second marbles are red. So you've got 3 red and 7 blue, so that's 7 or 10 total. So the probability of getting red is 3 out of 10. And since you put it back, the other one is also 3 out of 10. So that would be about 0.09%. I'm sorry, 0.09, which would be about 9%. Sorry. So that is it. Make sure you're coming to class, and I will see you guys later.